Hello, today we're going to be talking about notes 14-3 on slope. And at first it may seem a little bit confusing, but after we get through the notes, hopefully we'll feel a little bit better. So it says that slope describes the steepness of a line in the coordinate plane. So the slope of a line is the ratio of the vertical change to the horizontal change. So if you are somebody that skis, then obviously, if you're somebody that's been doing it a while, you can go down a steeper line, so that would be something that has a greater slope. And if you were somebody that was just starting out, you probably would want more of a minimal slope, so that would be closer to 0. So the key here again is that it says a ratio, which means your slope is usually going to be a fraction. So they say here that your slope is equivalent to the vertical change, which we are also calling the rise, divided by the horizontal change, which we call the run. So this can also be read as the rise over run. So in this example, they're showing you from this point to this point. They're picking any 2 points on this line. They went up 2 points, or 3 points, excuse me, and then over 2 units to the right. So to set that up as a ratio, it's just 3 to 2, so the slope is 3/2. You can reduce that to 1.5 if you want, but most of the time it's just written as an improper fraction. So question number 1, they're giving you examples of some possible slopes here. So the easiest way that I do this is kind of model exactly what they did in the key concept. That the 2 points that are given to you, if I start here and I draw kind of a triangle, a right triangle from those 2 points, I can now count how far did I rise and then how far did I run. So I rose 2 and I ran 3. So in this case, this slope is going to be 2/3. And that is one of my choices. And I want you to notice that that one, because our graphs are using the same scale and the boxes are very similar, notice that this graph, the steepness, is much steeper because that was 3/2 than this graph that was 2/3. So the steeper the line, the larger the slope is going to be. This one, I'm going to draw a right triangle again from this point to this point. And this, I'm counting the boxes between them. This goes 1, 2, 3, so that's a total of 3. And then I'm running 1, 2, 3, 4, 5. So 5, so my slope would be 3/5. Now the next one, if you notice, on this first one, the slope went up towards the right. The second one went up towards the right. So both of those had a positive slope. This one is going down. So this one ends up having a negative slope. So if I say, okay, make my right triangle, and you can make the right triangle either this way or below the line like this. Either one would be fine. This one, my rise is -1, and my run is 4, so my slope ends up being -4. The other way that you would know that this was negative is because they say the vertical change, so you could subtract your coordinates to figure out what your slope is going to be as well, which I can go over that. So if you guys could give number 2 a try. So this one has a slope of 2/1, or we could just say 2. It is okay to reduce it to that one. So question number 3 is saying that one of your friends describes the slope of a line as the x-coordinates increase by 2, the y-coordinates decrease by 5. So x increases by 2, they're saying that the y decreases by 5. Your other friend describes the slope of the line as the x decreases by 2, then the y-coordinate increases by 5. So you can see they're explaining the exact opposite. So is it possible for your friends to actually be describing the same line? So to show this to you, this triangle here means change in y. And I believe you've seen that in science. So this is the change in y over the change in x. The first friend said a positive, for the y, she said a -5 and then a +2 because they were increasing and decreasing. The second friend if again thinking of the y to the x, she said, or he said, either one, that that is a positive 5 divided by a negative 2. And if you notice in both of these, they are actually equivalent, because remember that negative sign can float between the numerator and the denominator, and they end up being equal. So are they explaining the same line? They actually are. So how we're going to go over this next part is what I was saying we were going to go over in a minute. This is now actually taking the coordinates and subtracting the coordinates. So this is one that if you're afraid of forgetting that the slope is negative just because of the way the line is traveling, this one will help you figure out if your line is positive or negative. So they're saying that you can find slope of the line by subtracting the coordinates of any 2 points on the line. The first y coordinate you use for the rise must belong to the same first point as the first x coordinate you use for the run. So what they're showing to us here is that if we chose this point and this point, for the change in y coordinates, so let's remember that our x and y coordinates always go x, y, and this is the x and this is the y. They first chose the 3 from here. That meant that when they went to subtract their x's, they had to choose this one first as well. So they took our 2 y coordinates and went 3 minus 0, which equals 3. They took our 2 x coordinates, the negative 4 and the 2, subtracted those. They rewrote this as an addition problem. They just didn't show you the work to get negative 6, which then reduces down to negative 1/2. And if you're worried about which one you choose first, again, no matter what way you choose it, as long as you choose the same coordinate from the same coordinate pair first, you'll be fine. So for number 4, they're asking, what is the slope of the line that passes through each pair of points? So I'm just going to go back up here again. They wrote change in y coordinates, so I'm just going to put this next to it, change in y divided by change in x. So again, we're thinking slope, which is the y divided by the x, the change in y divided by the change in x. And you can choose this however order you want. So because I've got this negative here, I'm going to say, okay, I'm going to choose this one first. So that means I'm going to do 2 minus 4 all over. Since I used this 2 first, I now have to use the negative 3 first. So 3 minus the 2. I then need to use my integers again. So there's the integer rules popping up one more time. I get negative 2 divided by negative 5. So that reduces to a positive 2/5. For b, if again I choose this coordinate, this set of coordinates first, that's the ones I have to label first both times. So it'll be 1 minus negative 5 and 6 minus 8. You would get the same answer if you did negative 5 minus 1 over 8 minus 6. It actually would give you the same slopes. So 1 minus negative 5 becomes 1 plus 5. 6 minus 8 becomes 6 plus negative 8. So it's going to be 6 divided by negative 2, which is equivalent to negative 3. So your slope will be negative 3. The next one is going to be 4 minus 4, and then negative 2 minus 1, which will be equivalent to 0 over negative 3, which is just 0. Okay? So give number 5 a shot. And my final answer here, again, I'm just trying to show you both ways that will give you the same answer, and I'm showing you in 2 different colors. That if you decided to go negative 3 minus negative 2, you would get negative 1/6. Or if you chose the second set first, you can go negative 2 minus negative 3, and again, you will still end up with getting the negative 1/6 at the end. Number 6, this one says that the line shown has an undefined slope, and they want us to use the points shown to explain why. So they are giving us 3, 3, and 3, 1. So if I take the 3 minus the 1, the 2x, these are my y coordinates, and then do the 3 minus 3, you'll notice that you get a 0 in the denominator. This means that this fraction is undefined. And we've talked about this before. that with this statement, no, that is not okay when you have a 0 in the denominator, but it is okay, so sorry, should be equal sign, but it is okay to have the 0 in the numerator. So when you have a 0 in the denominator, it's considered undefined. So for this next one, I'm going to show this in 2 different colors just so that it helps you see the difference between the coordinate plane and the line. So I'm going to draw a coordinate plane for all of these. So we need to remind ourselves that this is your x, this is your y. A positive slope is a line with a positive slope slants upward from left to right, so something like that is a positive slope. A negative slope slants downward from left to right, so starting up here, moving down, negative slope. A 0 slope is a slope that is horizontal because there is no rise to it at all. You're rising and then you can run an indefinite amount. An undefined slope, we just did that one, is a vertical slope. Okay. Question number 7 says that a building code for a ramp recommends that the ramp should rise no more than 1 inch for every 12 inches of length. Does the ramp shown meet the building code, and how do you know? So, just to remind ourselves, the run is what always goes horizontal. The rise will either go vertical, up or down. The run is the one because that is your change in your x. The rise is the verticals, that's your change in y. So if I look at the rise divided by the run, 8/70 is equivalent to approximately 114 thousandths. If I take the slope that they told us, which said that the ramp should rise no more than 1 inch, so that's your rise, for every 12 inches of length, that's your run. That is equivalent to 83 thousandths with the 3 repeating. So because the slope that we have for the ramp is greater than what is recommended, the slope does not meet building code. This is the ramp. Is greater than the building code. Okay. And go ahead, take a look at number 8. So they're asking which roof is steeper. Roof A with a rise of 12 or under run of 7. So rise, the run again, just as a reminder to yourself. The B was 8/4. So if comparing these, it looks like roof B is the one that is steeper because 2 is greater than 1 71/100. So when we've talked about slope today, we've actually talked about it in 3 different ways. We've talked about it as the rise divided by run. We've talked about it as the change in y and change in x with the triangles, or actually writing out change in y and change in x, and then also subtracting your coordinates. So if you have any questions on this, please don't be afraid to ask, and we will see you later. Have a great night.